Hello learners and welcome to your natural sciences lesson. So today we're going to be looking at the reaction between acids and metal oxides. We are further going to be looking at what happens when non-metal oxides are dissolved in water. But before we start, did you know that carbonic acid is found in all fizzy drinks and produced by dissolving of carbon dioxide in H2O? So whenever we're dissolving carbon dioxide in H2O, we are getting something called a carbonic acid, and that is found in all fizzy drinks that we normally drink almost every day. Right. In this lesson, as we have said, we're going to be looking at what happens or the reaction between an acid and metal oxide. So for us to get there are certain goals that you're going to be outlining. Now those goals are, I want you by the end of this lesson to know how to balance chemical equations. I also want you to be able to identify salt and water as the products of the reaction of an acid with a metal oxide. So when an acid reacts with a metal oxide, the products are going to be salt and water. I want you to be able to identify them in a chemical equation given to you. Now lastly, I want you to be able to state the general equation for the reaction of an acid with a metal oxide. So you need to be able to state the general equation of when an acid reacts with a metal oxide. Remember, we are still going to be looking at what happens when a non-metal oxide dissolves in water. So now, our main idea being the general reaction of an acid with a metal oxide. So we're going to start with looking at what is a metal oxide and how do we get a metal oxide. So our first point will be now looking at the metal oxide, and then further go on to looking at the pH of non-metal oxide solution. So what happens now when this non-metal oxide is dissolved in water? What is going to be the pH of that solution when a non-metal oxide is dissolved in water? So with this information, I know that there are certain things that we know. So let's just go through what we know about the acids and also about this entire lesson before we even start. There are certain things that we know. So to start, we know that the products of the reaction between an acid and a base is salt and water. So whenever an acid reacts with a base, we're going to get salt and water, right? And then the reaction between an acid and a base is called a neutralization reaction. It's called a neutralization reaction because the acid reacting with the base, they're going to neutralize each other depending on the strength of each of the two substances that are reacting. So the strength of the acid needs to correspond with the strength of the base, so that we can call that reaction a neutralization reaction. Should it happen that the acid has a greater strength as compared to the base, then the solution that you're going to be getting after that, or rather the product, is going to be more acidic because the pH of the product is determined by the strength of the two reactants. We also know that a neutral substance has a pH of 7. We know that in terms of our pH scale, we have that it starts from 0 all the way to 14, whereas 7 is a neutral substance. That's where you find our neutral substances, being water. And then we know that once you go below 7, we're going to more acidic. So the further we move away from 7 closer to 0, we're getting the strength of the acid becomes stronger and stronger. And the further we move away from 7 towards 14, the strength of the base becomes stronger and stronger. So it moves stronger as you're moving away from 7 towards 14, and that's now going to be the base, and then more stronger as you're moving away from 7 towards 0, that's going to be the acid. But at 7, we have a neutral substance. We also know that the pH of the product depends on the relative strength of the acid and the base. So as we have said, whenever we are reacting the two substances, either being a base and an acid, the product that is going to be determined by the two substances, its pH will be dependent on the strength of either the acid or the base. Should the strength of the base be greater than the strength of the acid, then the solution or the product is going to be more basic. But should the acid have a greater strength as compared to the base, then the product is going to be more acidic. But should they complement each other, should they be around the same strength, then the substance is going to be around 7. It's going to be more neutral as compared to the first two instances. So, with what we know, can we then be able to answer the following questions that are based on what you already know about this lesson? The question given to us here is, write down the general acid-base reaction equation. So in general, what's the acid-base reaction equation? We do know that whenever we are having an acid that reacts with a base, the product is going to be salt and water. And we do know that we generally refer to this reaction as a neutralization reaction because the strength of the acid and the strength of the base, they're going to be complementing each other, being around the same range, therefore they can neutralize each other. Now, our second question says, when a metal hydroxide reacts with an acid, a salt and something will be formed. We do know that the hydroxide is actually, it has a chemical equation, a chemical formula of OH. So all the hydroxides have an OH. So now we know that this is a metal. So a metal hydroxide reacting with an acid, salt and water. Salt and water will be formed. Remember, from what we know that an acid, all the acids, they all have an H within them. So they all have a hydrogen. So if we have a metal hydroxide, the hydroxide is going to be donated from the base, and then the hydrogen is going to be donated from the acid. So the reaction of those two, when those two substances combine, the H from an acid and the OH from the base, they're going to form our H2O, being the salt, then being the water, and then the remainder of everything is going to be the salt. And remember again that the salt's pH is going to be dependent on the strength of either the acid or the base. Question C. The pH ranges, or the pH scale ranges between the values 0 and 14. So our pH scale starts from 0, goes all the way to 14, where we know that in the middle there, 7, that's where you find our neutral substances. Below 7, we have acids. Above 7, we have our bases. And then at 7, we have a neutral substance. So anything that is around 7, be it a 5 or a 6 or even an 8 and a 9, we can say that those substances are either weak bases or weak acids, depending on which side we're looking at. If it's 8 or 9, that substance can be regarded as a weak base. If it's 5 or 6, it's going to be a weak acid because it's still below 7. Right. With what we have answered now, we also need to take a look at certain words that you're going to be using throughout this lesson to better explain it, to better understand what you're going to be talking about. So in this lesson, we're going to be looking at words such as an acid, a base, and pH value. We need to know what those words mean. So an acid now, that's a substance that tastes sour and feels rough on one's finger. Also, the acids, they have a pH that is less than 7. You always need to remember or think of the pH scale from 0 to 14, and then we have 7 there in the center. Now, anything below 7 will be acidic, and then anything above 7 is going to be basic. So the acids, they have a pH that is less than 7, so going towards 0. Then a base now, by definition now, those are going to be the substances we're describing a base now. That's a substance that tastes bitter and feels slippery in one's hand. And also, the pH of the base is going to be greater than 7. So with an acid, it's less than 7, but with the base, it's going to be greater than 7. Now, there's something else called a neutral substance that now has a pH of 7. Then a pH value, that's now the measure of acidity or the basicity of a substance. So whenever you're told that a substance has a pH of 3, then you know that it is measuring the acidity of the substance, that it's a strong acid, because the closer you move towards 0, away from 7, the strength of that particular substance increases. So the pH value is now the measure of the acidity or the basicity of a substance. Now, before we get started, learners, we're just going to quickly go for a short break, and I'll see you just after this.